So whenever you use objective benchmarks, the object of the exercise is to get to a single number. So let's assume you were checking the difference between CBR and constrained VBR, both at 1080p at 2.5 megabits per second. And say we're measuring VMAF, and the 200% constrained VBR comes in at 79.28, which means the quality should be between good and excellent. And one pass CBR comes in at 79.07. So it's just a little bit different, not a major differential there. So because CBR is a one-pass technology, it's going to produce the files much more quickly than two-pass. So you may make the decision here, well, hey, let's just go with one pass because we're cutting encoding time in half. But if you start to look at the data beneath the number, you'll see that that might be a very bad decision. So this is the results plot that you get from the Moscow State University tool. So VQMT is the video quality measurement tool. And what we're seeing here is the CBR file is in red and the constrained VBR file is in green. And this is the duration of the entire file, and this is the VMAF score. And then this region down here is the selected region in the top. So what you can do with this tool is you plot the scores, and you immediately see that there are a lot of places where the one-pass CBR quality drops substantially below that of the two-pass constrained VBR. And, here's a couple of highlighted areas. Now, then you go, if you click Show Frame here, you go to the frame, and you can toggle through the 3 frames in the analysis. And when I say 3 frames, I mean this is the original file. This is constrained VBR, not perfect, but certainly a whole lot better than this. So what we're seeing is that for these short frames here, there is a substantial quality hit associated with using CBR. So what we've done is we looked at the number, we looked at the plot, we looked at some frames in the plot, and then we see, okay, well, there's substantial differences, but would a viewer see the difference in the context of a video playing in real time? Because 1 or 2 frames may be something that people just don't notice, and you really hate to disregard a technology because of a single bad frame or a couple of bad frames in order. And you see down here, it really is, 1 or 2 bad frames, and then the quality jumps right back up. So what I do if I'm doing a pretty big analysis, whether it's a product review or a consulting project where I'm analyzing different encoding tools, is I load the videos into a tool like Premiere Pro. So I would create a separate timeline. It would be constrained VBR on one track, CBR on the other track, and then a title so I can tell the difference. And here's CBR, here's constrained VBR. And then I actually produce the video, I output the video in those regions that we saw, and then I play the video a few times to see if you actually can notice the difference. And then, if I'm working for a consulting project, I can produce the video file and show that to the client. If I'm working on an article, I can produce the video and make that available to readers. But really, the analysis we're doing is, number one, we're getting to the numbers that we saw here. Then we're looking at the results plot here. Then we're looking at the frames. And then finally, we're putting the videos into Premiere Pro, which is a video editor, and looking at the differences.